السلام عليكم ورحمة الله وبركاته. My name is Rowyhi. I am a senior industrial engineering student at the University of Jeddah, and today I will be presenting a presentation about how to apply GA using xlOptimizer. So first of all, a quick introduction. What is the xlOptimizer? It is a Microsoft Excel add-in that optimizes complex problems and uses many algorithms that tackle these problems. So what are the kinds of problems that we can solve? We can solve engineering problems, finance problems, manufacturing problems, such as simple OR problems. We can also solve using xlOptimizer scheduling problems and resource allocation and route finding problem, such as the traveling salesman. So what are the pros of xlOptimizer in comparison to other competitors? Modern and compatible with the newest version of Excel, unlike other alternatives that only work on 2006 and 2007 Excel. It has an easy user interface and provides many new algorithms to tackle complex problems, and it saves results as a log file so you can analyze it later. So what are the algorithms provided? There is the GA genetic algorithm that we'll be explaining later when doing an example. We have the standard and the permutation that take consideration of the order. Then we have the particle swarm optimization. Then also provided the differential evolution, which with its 5 kinds. Then also the greedy ascent hill climber, which will be shown later how it is integrated into the GA. Then we have stimulated annealing, which focuses on the heating and cooling of crystals, and also the artificial bee colony, which simulates the movement of the bees in a colony. And then multi-objective optimization can be implemented as well with the NSGA3 algorithm. So now we'll do a quick example and show how to apply GA using xlOptimizer. So now continuing the second part of the video, which is the simple example. Here in this example, we are trying to minimize the cost of the purchase of light bulbs and under certain given constraints, which are the constraints here. We are trying to buy at least 521 light bulbs, and then the maximum stock of each package is 14. So A, B, C, D, and E are the packages with their cost and their quantity. And we are trying, the constraint is that it has a maximum stock of 14. So when downloading the xlOptimizer, you will automatically have this menu added to your main menu, which shows your xlOptimizer, and then we can play with these according to your problem. So let's specify our objective, which is minimizing the total cost. Let's check here that we are trying to minimize. Then we have the decision variables. What are our decision variables? It is the quantity of the packages, which accordingly is the number of light bulbs produced, and the cost, which has great interest to us. So let's here change it, and then we can specify a constraint, which is the upper bound, which is 14, the maximum stock of each package. And then let's change it step to 1, so it does not return decimal numbers. And then we have the one constraint left, which is the number of light bulbs produced, which is this cell right here. And what is the constraint? It is at least 521. And then let's put the penalty function to a large number. So every time it does not fulfill this constraint, it will add to the objective function. But if you have a maximization problem, you put it as a negative penalty function. And then the last thing we have left is the scenario or the algorithm used. And then here, xlOptimizer provides how you can generate your random number, and then a log file, which is data used for analysis. And then we have the termination criteria, which is the stopping point of the runs. So let's put it as here for the evaluations, let's put it as 5,000. And then the minutes as 1.5 minutes. So we don't take that much of time. And then here you can choose the algorithm. And then what we are focused on are the standard GA. So what is the standard GA parameters given here? Is the first one we have here, is the population. So default is 50. What does the population mean? It is the number of chromosomes used or the family used. So let's put it at 75, because when increasing the population, you will increase diversity, and then it will enhance the quality of the solution. And then we have 3 types of selection. We have the tournament, roulette wheel, and stochastic. So what is the tournament selection? It selects according to the tournament size, and the probability is chooses the best individual with a probability of the given. So here we put it as 1, so it chooses the number 1 champion between the two. And then we have the roulette wheel, which is based on the fitness function provided according to your problem. We will not use it in this problem. And then you can also use the SAS, stochastic universal sampling, which is the same as the roulette wheel, but it has no bias and minimal spread. So then we have the crossover methods. We have single, double, and uniform. So what is the single? Single, it cuts a single cut through the chromosome and then switches it with another chromosome. Double is two cuts. Uniform is randomly and by uniform cuts. And then the probability of it happening can be specified. So let's change it to 0.8 so we can increase the crossover happening. And then we have the offspring. We can either choose it as 1 or 2, which increases diversity. So then we have the operator mutation, which mutates the gene inside the chromosome. We have two types. We have the jump or the bit flip, which changes the genes from 0 to 1, 0 to 1 or 1 to 0. And then we have the creep, which adds or decreases the certain gene value. And then we have the final operator, which is iltism, which iltism copies the best candidate. For example, 1, so it chooses the best one. So if you choose 2, you can choose 2. And then we have the greedy descent hill climber, which specified before is another algorithm. It is integrated into the GA to enhance the quality of the solution. So here you can specify its probability. So after finishing all these conditions you specify, you go to the single objective and then you run it to see how it works. And see, as shown here, it is running and looking for solutions. And now I will show you then the log file and how we can analyze it. So now opening the log file, it will show here the parameters you chose and then the constraints specified. And then here you can see here how the GA works, looking for solutions. And here this graph shows how the GA worked through the generations to find the optimum solution. And now going back to the original Excel sheet, I will show you how the optimum solution is found. So now here, as shown, the package numbers and quantities with the total cost and the light bulbs. And this answer is the minimum solution according to the parameters you entered in the GA. But changing the parameters and changing the tournament size, for example, and the crossover and mutation probabilities, you'll get a different answer. So more studies needed to have a better optimum solution. And this is the end of my video, and I hope everything was clear. And thank you for watching and listening.